Okay, class, this is equation 4, and we derived equation 2, so we can use this with equation 1 and equation 3. So we're going to use all three of the first equations to derive equation 4 here. And so this is going to be a quadratic equation for position as a function of time, which means that the position depends on the square, or is proportional to the square of the time, and also the initial velocity. Okay, so I have them written out here. Equation 3, 2, and 1. We're going to start out with equation 3, which I have here. And we're going to add the initial velocity, V0, to both sides and divide by 2. So I add it to this side and divide by 2 to the left-hand side. I add it to the right-hand side and divide by 2. And since I'm adding another one to this, this will become a whole instead of a half. So you can work that out for yourself if you'd like. Just move that down a little bit. Okay, so once we get to there, we know that we use equation 2 for the average velocity. We can see that V0, initial velocity, plus the velocity that depends on time divided by 2 is the average velocity. So that's equation 2 right there. Equation 2 right there goes to here, and then we keep the same side on the right-hand side. And then we go to equation 1, and we notice that, in equation 1, we also have the average velocity on this side. So we're going to take the average velocity that we got from equation 3, and we're going to plug it into equation 1. So equation 1 down here, x as a function of t equals the initial position, x0, plus what we plug in for the average velocity, which is there and is there in that one. So basically, I take this whole equation and then I plug it in right there to get that. You get that right there. So it actually goes this part. And I think you should all be able to see this fine. I'm just making this extra clear. Goes there. Right there. Okay. So then we distribute that t there, and we get a t squared for at over 2 becomes a t squared over 2. We distribute the t to the initial velocity, v0 times t, and then our initial position. And we have a complete function of position with respect to time variable. And all we need to know is these three things, basically: our initial position, our initial velocity, and our acceleration there. And oftentimes that'll be gravity. So I would say this is probably the most important of the 5 equations of motion that we have, is this one right here, which is the position function with respect to the time variable, which is quadratic and time proportional to t squared. So that's equation 4. I hope that helps, and I'll move on to our last equation, equation 5.